Copyrights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.
Hello students, welcome to Chand Academy, the official YouTube channel of Chand Publishing. The book is Mathematics for IIT-JEE Main and Advanced by M.L. Khanna sir, and I am Subuh Nadeem, giving you the videos of this book, some selected topics and exercises. So the chapter here is chapter number 28, limits, continuity and differentiability. And we have few theories related to it first. So what are those theories? Let us see. First of all, limit. What is a limit? This is a value of a function at x approaching a. Then we say that the left hand limit is when we approach a from left of a. That is x tending towards a minus fx, which we can also say as f of a minus, or we can also say limit h tending towards 0 f of a minus h. Similarly, right hand limit is there, which is said to be limit x tending towards a plus f of x, which is equal to f of a plus, and it is equal to limit h tending towards 0 f of a plus n. So this is how we define limit, and there are few results related to the limit. For example, limit x tending towards 0 sin x upon x is equal to 1. Limit of x tending towards a, x to the power n minus a to the power n by x minus a is equal to n a to the power n minus 1. Then we have limit x tending towards 0 log of 1 plus x by x, it is equal to 1. And then we have LH rule. So LH rule is one more result you can remember, e to the power x minus 1 by x. This is minus sign here. So let me write it again. This is a minus sign. So if we take e to the power x minus 1, limit x tending towards 0, it will be equal to 1. And then we have few more results. Before that, we have to see that what is LH rule, L'Hopital rule. So LH rule is, we have if a function fx by gx is given, limit x tending towards a is there, and it is actually of the form either 0 by 0 or infinity by infinity form, then in such situation we can differentiate the numerator and the denominator separately, and then we can apply the limit. So this is LH rule, which is very important. Then we have the concept of continuity. The concept of continuity is, if we have a function continuous at a point, then its left hand limit is equal to its right hand limit is equal to the value of the function at that point. If it is continuous in an interval a closed to b closed, so in this interval f of a should be equal to f of a plus, and f of b minus should be equal to f of b. Further, for any point c belonging to a comma b open interval, f of c minus is equal to f of c plus is equal to f of c. So this is the condition for continuity at a point. This is a condition for continuity at an interval. Now we have another thing, which is differentiability. So if we talk about differentiability, in differentiability, if we differentiate a function, we say that its derivative f dash of x is equal to f of x plus h minus f of x by h, limit h tending towards 0. Now what happens here? There is again left hand derivative and right hand derivative. If it is left hand derivative, we take h tending towards 0 minus, and if it is right hand derivative, we take h tending towards 0 plus. And we say it is differentiable if left hand derivative is equal to right hand derivative. Differentiable if left hand derivative is equal to right hand derivative. Now, after knowing these results, and some of the results which you can see from the book also, we can come to few questions here. So as we see, this is the first question: limit extending towards infinity x cos pi by 4x sin pi by 4x. That is what we have to find. So what we write it as, we say that this is limit t tending towards 0. Why we say t tending towards 0? Because t can be written as 1 by x. And if x is tending towards infinity, t is tending towards 0. So this is what we have done here. T is equal to 1 by x. And this is written as 1 by x cos of pi by 4t into sine by pi by 4t. This is how we can write. Now in the next step, what we can do, limit t tending towards 0 and cos pi by 4t, I'm writing separately, into limit t tending towards 0, and then we have sine pi by 4t, and we have 1 by t here. This is not x, this is t, because x is 1 by t. So as we know here, this is t here. So when we write t, this will become t here. Now what else we have to do? Since it is sine pi by 4t, but it is t, so we will multiply by pi by 4 here, multiply by pi by 4 here also. So this will become, after putting the limit, what will we get? We will get this value when t is equal to 0, cos 0 is 1, and here sin x by x, limit x tending towards 0 is 1. So this value will be 1, as t tending towards 0 means pi by 4t is also tending towards 0 into pi by 4. So finally, what answer we are getting? It is equal to pi by 4. So let us move on to the next question. Next question is limit extending towards 0, p to the power x plus q to the power x plus r to the power x by 3 to the power 2 by x, where p, q, r are positive. So if we calculate this, we can see here we have an identity which says that 1 plus 1 by x to the power x, limit x tending towards infinity is equal to e. We can also say that limit x tending towards 0, 1 plus x to the power 1 by x is equal to e. Anyways, we can write this identity. So this is 1 to the power infinity form. Now, if we apply this identity here, how can we apply it? So we take it like this, that this is 1 plus p to the power x plus q to the power x plus r to the power x minus 3 by 3 to the power 2 by x. We can write it like this. So after writing it like this, we can, in the next step, take this as a quantity. As you can see here, if x is approaching 0, so we can consider this as x, or let us suppose this is t. So when you take x tending towards 0, what will happen? This will become 1 plus 1 plus 1 minus 3, that is 3 minus 3, 0. Now there is a value which is 2 by x here. So in order to compensate it, what we have to do? We have to multiply by p to the power x plus q to the power x plus r to the power x by 3 minus 3 in the denominator, and same thing p to the power x plus q to the power x plus r to the power x minus 3 by 3 in the numerator. So we do like this. Now when we do this, what happens in the next step is this is 1 plus x to the power, this term actually is 1 by x, which is e. So we can say e is coming here and limit x tending towards 0. What else is remaining is actually 2 by 3 p to the power x plus q to the power x plus r to the power x minus 3 by x. This is what is remaining here. So p to the power x plus q to the power x plus r to the power x, this is minus 3 by x is there. And in the next step, we will take it as e to the power limit x tending towards 0, and it is 2 by 3. And we can write it as p to the power x minus 1 by x plus q to the power x minus 1 by x plus r to the power x minus 1 by x, like this. Now, as you can see, a to the power x minus 1 by x, limit x tending towards 0 is log of a. So this will become e to the power 2 by 3 log of p plus log of q plus log of r. So this will become e to the power 2 by 3 log of pqr. Or you can say this will become finally pqr to the power 2 by 3, as e and log will get cancelled. So in the next question, let us see what we have. The next question says sin x minus x by x cubed limit x tending towards 0. This is what we have to find here. So if we see, this is actually 0 by 0 form. So let us apply LH rule. If we apply LH rule, this will become cos x, this will become 1, and this will become 3x square after differentiating, and limit x is tending towards 0. So this is limit x tending towards 0, and cos x minus 1 is minus 2 sin square x by 2 upon 3x square is there. Now in the next step, we can write minus 2 by 3 sin x by 2 whole square, and here also x by 2 whole square. So this will become 1 by 4 again. 4 and 4 will get cancelled. So this will become minus 1 by 6 into 1 as limit x tending towards 0. So this is minus 1 by 6 finally as our answer. So what we have done here, first we have applied LH rule. After applying LH rule, then we have applied sin x by x limit x tending towards 0 formula. Now let us come to the next question. Determine the values of a, b, c for which the function is continuous at x is equal to 0. So if it is continuous at x is equal to 0, what we have to keep here in mind? We have to keep here in mind that the left hand limit is equal to right hand limit is equal to value of the function at the point. So left hand limit is for x tending towards 0 minus. So we have to find the limit. Limit x tending towards 0 minus. This is sine of a plus 1x plus sin x by x. What this value will become? As you know, sine of a plus 1x by x is there. So a plus 1 will be divided and multiplied. So it will give a plus 1 plus sin x by x. That will be 1. So it will be a plus 2. If we talk about for x is equal to 0, it is c. So for x is equal to 0, the function value is c. And for 0 plus, if we take limit x tending towards 0 plus, we have this function. And this function, when we take it, this is 0 by 0 form. So what we will do, first let us take x to the power 1 by 2 common in the numerator. And we have 1 plus bx to the power 1 by 2 minus 1 by bx to the power 3 by 2. Now x to the power 1 by 2 you can cancel, and you will get limit x tending towards 0 plus 1 plus bx to the power 1 by 2 minus 1 by bx, like this. This is what we can write here. In the next step, what we can do, this is actually 1 plus bx to the power 1 by 2 minus 1. And the denominator is 1 plus bx minus 1. So limit x tending towards 0 plus is there. So if you take the formula x to the power n minus a to the power n by x minus a, this will be n a to the power n minus 1. So n a to the power n minus 1. So it will be 0. It will be half. So what we come to the conclusion here is it is half 1 to the power n minus 1. So it is 0, not half, 0 actually it is. If you see here, it is minus half. However, it does not matter. So it is half. So if we equate a plus 2 and we equate c and we equate half, the value of a plus 2 will be equal to half, which means a is equal to minus 3 by 2. And value of c will be equal to half. So this is the value of a, this is the value of c, and b can be any real number, which is not 0. So b can be any real number except 0, as in that case it won't be defined. So we can say that this is a is equal to minus 3 by 2, c is equal to half, and b is real number except 0. Let us come to the next question. A function f(x) is defined like this. For x square not equal to 1, it is greatest integer of x square minus 1 by x square minus 1. And for x square equal to 1, it is 0. Discuss the continuity of function f(x) at x is equal to 1. So this is the function at x equal to 1. Its continuity we have to discuss. So left hand limit, let us calculate. Limit x tending towards 1 minus. So if we take limit x tending towards 1 minus, we have the function as x square greatest integer minus 1 by x square minus 1. Now 1 minus is slightly less than 1, and its square will be slightly less than 1. So it will be 0. 0 minus 1 by x square minus 1. Limit x tending towards 1 minus. So this will be a quantity which is slightly less than 1, and this is 1. So the difference will be a value which is almost 0 but slightly less than 0. So this will be infinity finally. If we talk about the right hand limit, what will happen? Limit x tending towards 1 plus and greatest integer of x square minus 1 by x square minus 1. So this is limit x tending towards 1 plus. Now this is slightly greater than 1. Its greatest integer will be 1. So 1 minus 1 by x square minus 1. This will be exactly 0 by some quantity, which will be 0. And value of the function at 1 is actually 0. So we see that the right hand limit and the value of the function at 1 are same, but is not equal to the left hand limit. Now let us come to the next question. Verify Lagrange's mean value theorem for the following function. So what was Lagrange's mean value theorem? As we have here, the function f(x) is equal to sin x and f dash x is equal to cos x, which is actually equal to f of pi by 2 minus f of 0 by pi by 2 minus 0 if this is differentiable and continuous in 0 comma pi by 2. So sin x's graph is between 0 and pi by 2 like this, which is actually differentiable and continuous in 0 comma pi by 2. So we say that we can apply Lagrange's mean value theorem. Now when we write like this, then cos x will be equal to f pi by 2, that will be sin pi by 2, 1, f0 will be 0 by pi by 2 like this. So this will become 2 by pi. So cos x is equal to 2 by pi. So there is a value x is equal to cos inverse of 2 by pi, which will be an angle somewhere here, and that angle will be the value between a and b such that f dash of c is equal to fb minus fa by b minus a. So this was Lagrange's mean value theorem, which is verified for this value. So this is, you can also say c. This is c and this is c here. The next question, let us come to the next question here. verify Rolle's theorem for fx is equal to this function is minus 3 comma 0. So first of all, let us see whether this function is differentiable or continuous or not. So this function is, of course, continuous in minus 3 comma 0 and differentiable also, because it is algebraic expression and here it is exponential. So it is differentiable and continuous. Further, if it is asked that find the value c, so f dash of c should be equal to 0. But that is possible only if f of minus 3 is equal to f of 0. Now f of minus 3 if you take, that will be 0. And f of 0 when you will take, that will also be 0. So they are equal to each other. So we can apply Rolle's theorem. Now we apply f dash c. So derivative of fx is f dash x, which is x into x plus 3 into e to the power minus x by 2 into minus half plus x plus 3 into e to the power minus x by 2 plus x e to the power minus x by 2. So what we get? E to the power minus x by 2, and this will become minus x square by 2 minus 3 by 2x plus x plus 3 plus x again, like this. So what we are getting here is e to the power minus x by 2. This is minus x square. This is minus 3x. And this is plus 2x. So 4x minus 3x is x. And plus 6 upon 2. This is what we are getting. So this can be written as e to the power minus x by 2. And this minus you can take outside. And you can say that this is x square minus x minus 6. Like this upon 2. So this is minus e to the power minus x by 2. X minus 3 into x plus 2 by 2, like this. So this is how we can write the derivative. As you expand, you can see that you will get the same term. Now if you equate it to 0, so when you equate it to 0, you will get x is equal to 3 and minus 2. So that is the value of series. You cannot take 3 because it is not in this interval, but minus 2 can be taken. So this c is minus 2. So for c is equal to minus 2, f dash of c is equal to 0 we have, which means that it is satisfying the Rolle's theorem fully. Now let us see the next question. So this is the next question with us. Limit extending towards 2, root over 1 minus cos 2x minus 2 by x minus 2. And when you calculate it, so what will happen? Limit extending towards 2, root over 1 minus cos 2x by 2 is root over 2 sine square x minus 2 by x minus 2. And this can be written as limit extending towards 2, root over 2 mod of sine x minus 2 by x minus 2. Now the important point here is whether you are approaching 2 from the left side or the right side. If you are approaching 2 from the left side, what will happen? If you are talking about the left hand limit, so in that situation, this will be a negative quantity. The quantity here is a negative quantity. If we are approaching from the left hand side, so it will give you a minus sign outside. So the final answer will be minus root 2. And if you are going for the right hand limit, so for the right hand limit, what will happen? For the right hand limit, this quantity will be a positive quantity. As x will be 2 plus. So this will be simply mod x sin x minus 2 as sin x minus 2. So this will be root 2. So minus root 2 and root 2 are not same. So we will say that its limit does not exist. So these are the questions for the time being. Thank you, students.